Hello all and welcome to my YouTube channel. Welcome to the LangGraph series where we are learning the LangGraph in depth. So this is the part 3 of this particular series, and in the previous part 2 we have already covered the basics of LangGraph, and also we have covered the conditional age management in the LangGraph. So if you have missed that particular videos by any chance, please go ahead and check out that. The links are available in the description below. Let's get started with today's video. So today we are going to focus on the memory management in LangGraph. So let's unfold the memory management concept in depth. So first of all, why do we need the memory, or why do we need to manage the memory whenever we are building the multi-agent framework? See, memory management is a very crucial topic, and why it is important, because whenever there is conversation happening across the agents, so let's say if you are building a multi-agent project and there is multiple conversation that is happening. Let's say you are calling multiple agents one after the another. So each agent needs to transfer that particular output generated by one agent to another agent or next fellow agent, right? Then only the next agent knows what exactly needs to be done. So whenever these conversations are happening, it becomes very cumbersome or to manage that particular conversation, and it becomes very hectic, as well as it becomes very costly operation to transfer all the conversation from one agent to another agent. And the better way is to summarize the conversation and then pass, plus remove some conversation, pass only the valid conversation. Those are other management parameters that are available in order to smoothly transfer the communication or smoothly transfer the conversation between the agents. So that's where it is very much important. And if we are not adding memory to our agents, right, then our agents will be like short-term memory loss patient, because they will not be able to remember anything. So let's unfold that memory management. So in this particular video, we are going to understand this particular travel assistant agent with memory and without memory. So we'll be seeing the example first without memory and then with memory. And these are the configurations that we'll be using. So please go through these notes. The notes will be available in the description below. So please go ahead and check out that as well. So we'll be using Gemini 1.5 Flash model. Again, we'll be using open source model. We don't want to unnecessarily spend money in order to learn the things, right? So first we'll be unfolding the without memory versus with memory graph, and then we'll be summarizing the memory with the help of some conditional edges, and then we'll see how exactly it operates. First of all, let's understand why the memory is required. So we have already covered these points. Memory allows agents to remember past interactions. Without memory, every user input is treated independently, and it doesn't make sense. And with memory, agents can reference earlier parts of the conversation. And why memory is required? In order to make the interactions more natural, like a human do, then help in multi-turn conversations like booking flights, remembering some shopping recommendations and all those details. Then it also reduces the repetition of work. User no need to put the details again and again in the messages. User can go ahead and ask follow-up questions easily. So that's where the memory is required. So let's understand the types of memory that are available. So there are two types of memory: the stateless memory, meaning no history, each query is independent, and the stateful with memory, meaning which maintains the context across turns. So enough of theory, let's see how exactly it works. Okay, so we will be requiring these dependencies: LangChain core, LangGraph, LangChain OpenAI, GraphViz in order to plot the graph structure, then LangChain Google GenAI in order to load the large language model from Google Gemini, and the LangChain. LangChain OpenAI is not required. If you are using OpenAI model, then it will be required. So let's go ahead and install the dependencies first. So along with that, we'll be using the LangSmith. So LangSmith is again a library which is developed by LangChain, and this is in order to trace the monitoring logs for our project. So with the help of LangSmith, we can easily build the production grade application, and also we can trace the application, how exactly the conversations are happening, how much tokens we have used, and all the model related tracings we are able to do that with the help of LangSmith. And LangSmith integration with LangGraph is very easy. You just need to create a LangChain. You just need to create a LangSmith API key. You need to pass that, and it will start capturing the model tracing. So you just need to enable this particular LangSmith tracing flag. So once you enable that, it will start capturing your logs. So first of all, you will have to create the LangSmith API key. So just go to LangSmith, log in with your Google account. it will just ask you to sign up with your with the Google account. You can go ahead and do that. So currently you can see in the projects we don't have any projects. So in order to create the key, you can go to settings and you can create API key. You can see API key option here. Just go ahead and create the API key from here. And you can select personal access token. You can select workspace as personal, and then you can add some description, let's say LangGraph Studio, and you can go ahead and create the key. So I have added, and you can click on create key, copy that key and pass it here. So I'll be deleting these keys before uploading this video. So make sure you are not exposing your secret. Then we need to give the LangSmith project name. So we are giving project name as iTech LangGraph. So iTech as our iTech is our YouTube channel. So if you are new to the YouTube channel, please go ahead and subscribe to the YouTube channel. And then we need to pass Google API key as well. This will help us to load the model. So again, for that, you can go to Google AI Studio, and from the API sections, you can create the API key. You can select the project if you have not created, and from there, you will be able to grab the API key. Just go ahead and click on create. It will create the API key for you. Again, this API key also, I'm going to delete it post the execution or before uploading the video. So make sure that you are not exposing your secrets. So let's go ahead and execute this. Now, this part is there in order to load the generative AI model. So we'll be using chat Google generative AI class that is from LangChain Google Gen AI. And we'll be using Gemini 1.5 flash model. And we have set temperature at 0. We have controlled the randomness of our model. And you can see those things we have imported from LangChain. You can see chat Google generative AI we have imported from LangChain Gen AI. And then chat prompt template is required in order to set the prompt template. So we have set the prompt template as in this particular format. You can see you are a simple travel assistant, and we have added some rules because this is a travel assistant. So we have added some basic rules, and again here we are passing the user message or conversation so far. And then we are creating a chain. So this is the latest way of creating the chain so that you can invoke that particular chain and you can start the conversation. So let's go ahead and execute that very simple code. We have already seen this in the previous videos. So if you have missed that, please go ahead and check out. Then let's understand the without memory part. So for without memory part, we have imported Statecraft. Again, Statecraft, if you are new to this, Statecraft is a initial graph state which help us create a graph framework first, or one structure of graph. On that structure, we can keep adding our nodes and edges later. So that's one thing. Again, we have covered this in the previous video. Then we are passing message state. Message state is in the form of a dictionary where it stores the message and the response. So again, that we have imported it from the LangGraph. You can create your, or you can define your own state as well. And then we have used the decorator stateless graph.add node. Now this decorator help us convert any Python function into a node or agent. So you can see here we have created, we have converted this particular travel agent function into a node. So you can see we have created travel agent function, and we have passed state, which is of the type message state, which is again a type ticked. Then in the responses, we are just invoking the chain. So this particular chain dot invoke message, and for that message, we are passing the state message that is coming. That we will be passing to the travel agent. So whatever message that is coming from user will pass this to the travel agent, and it will generate the response based on the travel chain. So for that travel chain, we have given the prompt. Based on this prompt, we will pass the user message and it will generate some response, and that response we are returning. Now the response we are returning along with the state message and response. This state message is nothing but user question, and that in that we have added the response as well. And then we have set the entry point for the graph as travel agent and finish point as travel agent, and then we have compiled it. So let me go ahead and execute that. And this is the small code which is in order to plot the graph structure that we have built. So you can see we have built the starting the conversation and then passing it to the travel agent, and from travel agent again we are ending the conversation. Very simple graph. Let's test this particular graph now. So as a user, we are passing the content. I want to go to Goa. Please help me with the itinerary. Now in this particular thing, based on the prompt that we have given, as it is a travel agent that we have built, it should go ahead and suggest me the itinerary, or at least ask some follow-up question. So let's see that what's happening. So we have run this particular code. So okay, you can see, okay, Goa, I can help you with an itinerary. What kind of things are you interested in doing there? So it is asking follow-up question. Now we are starting the second message, you can see this is just in order for you to showcase without a memory how weird this particular graph is going to behave. So now we are asking follow-up question. Okay, what are the good places to visit? If I'm asking this particular question, now what clearly observe that I don't know where you want to go yet. Please tell me your destination. As it is a travel agent, it is not able to recall what was the last question that user asked. User already told that user want to go to Goa. Now here, unnecessarily, I want to go ahead and add extra detail that okay, I want to go to Goa. What are the good places to visit there? So that's how without memory, there are a lot of challenges that we faced, and it is not advisable to keep our patient untreated with the short-term memory loss disease. So let's treat this particular disease with memory. So how exactly we are going to add the memory? So there is already a memory saver available in LangGraph. You can see we are importing that memory saver class, and we have created the memory object. And again, state graph, we are defining the graph state, and we have passed the message state. And again, with the help of decorator, we are adding node. Again, same thing we have created, just like before. Till this point, everything is same. Just we have created one extra object memory, and that memory object now, while compiling, we are passing to the passing it in the compile to this check pointer. Now this check pointer is going to create a checkpoint. Checkpoint meaning what? Capturing the metadata at particular point. That is checkpoint, right? Now it captures the timestamp value at this particular time or at this particular step. This was the conversation that happened. So that information it is going to capture, and where exactly it is going to store that on thread. So let's understand what exactly is the thread. But before that, let's execute this. Okay, so thread is nothing but it's a object which help the LangGraph to store the conversation that is happening. So you can create multiple threads based on the session management. If multiple users are logging into your application, you can assign them a separate thread so that you can track the conversation that is happening for individual users. So that's how those conversation you can manage on thread, or if user is starting the new uh, conversation, then you can pass that particular conversation on the new thread. So this is basically in order to manage the session history for the users. So for that purpose, we use the thread, and let's see how exactly the thread operates. So this is a very simple example that I have tried to cover. So for travel assistant, right, we have, let's say, graph. There are two nodes. First one is the user node where we are asking the question, let's say to plan a trip, and second one is the assistant, which is generating the response, which has suggested the itinerary. Now these two nodes are in sequence. So whenever the nodes are in sequence, it creates different checkpoints at each sequence. But if the nodes are in parallel, then it creates single checkpoint. How exactly this happens? For example, let's say there are these three nodes that we are talking about. Now, if you see this and these nodes are in sequence, right? In the execution pattern, these are in sequence, but these two nodes are running parallelly, right? If you see, these two nodes will run at same time. So for this one, it will create one checkpoint. And for these two nodes, it will create a single checkpoint. So that's how there will be two checkpoints created. If you are adding one more layer here, it will go ahead and create the another checkpoint for that. So that's how it will create multiple checkpoints. And for each checkpoint, there is super step, meaning super step is nothing but the execution of node. Once this node is executed, that conversation is nothing but the super step. You can see there is step one, step two. So for this one, it will be step one. For this, it will be step two. And here it will be step three. So that's how three-step conversation will happen. Then checkpoints. For each step, there is going to be one checkpoint, as I mentioned. For one step, for this step, there is one checkpoint. For this step, there is another checkpoint. So these two checkpoints we have created for these two steps. And thread is nothing but capturing these checkpoints. So you can see is the collection of, so thread is the collection of checkpoints. So let me show you that. You can see thread is a collection of checkpoints for this travel conversation. So on the thread, you can see we have captured the multiple checkpoints. So whenever required, we invoke this particular checkpoint, pass it to the node in order to continue the conversation. Okay. So whatever we have built here, let's visualize this, how exactly it looks like. So from user, we are passing the message to travel agent node. Travel agent node is going to save the context into memory saver, the checkpoint, and whenever required, it is going to recall that context and then accordingly help assistant to respond or generate the response. So let's see how it works. So for example, now if I am we are asking the question, I want to go to Goa, please help me with the itinerary. Same question we have asked. Let's see what exactly it is giving. Okay, Goa, I can help you with the itinerary. What kind of things are you interested in doing there? Now I'm asking question, follow-up question. What are the good places to visit? Now it should remember that it was for Goa. You can see, okay, Goa, it has remembered that some good places to visit in Goa include these Palolem Beach and other Old Goa and Dudhsagar Falls. All those details it has given, meaning it is now able to recall the memory. So we have uh, done the treatment for our patient, and now our patient is no more suffering for the short-term memory loss. It is able to remember the things that is happening or that have happened in the past. So with the help of this simple check pointer, we are able to add the memory. Very simple, right? Adding memory in LangGraph is very simple as compared to other agentic framework that are available out there. And specifically, I'm talking about the Autogen. In Autogen, again, I face a lot of issues while integrating the memory for the agentic framework. But yeah, with LangGraph, it is very much easy. The next and last topic that we have is extending the memory with summarization. But before that, let me go ahead and show you the conversation that we have captured or the tracing that have happened on the LangSmith. So let's jump to the LangSmith. And as we have created that particular project iTech, so if you go back and just refresh this, it should have created the iTech project. Okay, you can see iTech LangGraph project it has created. And you can see it has 4 execution. We have executed 4 examples if you remember. These 2 examples and the earlier 2 examples. Similarly, 4 examples. So let's go ahead and check out. If you open the project, you will be able to see that 4 examples. So if you click on first, that one we executed, where we ask the question, I want to go to Goa, please help me with the itinerary. And it has generated that, okay, Goa, I can help you with an itinerary. What kind of things are you interested in doing? And then in the second one, it forgot about what was the last question. So you can see it responded, I don't know where you want to go, please tell me. So apart from that, you can see LangSmith is capturing a lot of details. You can see which model it has used, it is adding that, which agent it called, it is capturing that, then what was the start time, end time, what was the status, and this is the main part, tokens, total tokens it has captured. And if you hover over that, you can see input cost 68.72%, output cost, meaning it has given the contribution of input cost versus output, meaning the cost it has took to generate to process the input versus generating the output. Now why the input cost is higher? Because we have prompt. Then later on, when I'll show you the with memory example, you will see the input cost will be higher than this, because percentage will be higher than this, because there we are passing summary as well. But for output, it is just generating 1 or 2 liner output. And then the final things it is giving, see, this was the cost that it incur. As it is a Gemini model, it is not charging us. But yeah, there are limitations on Gemini. I think you can hit 50 calls per hour, or some limitations are there. So if you are rigorously using that, the code will fail. Now let's go to the memory one, where we have asked some interesting question. Again, you can see where we have asked, okay, I want to go to Goa, please plan a trip. This was the question. And then we asked this particular question. Okay, what are the good places to visit? And now you can see it has remembered everything, whatever we passed earlier. Okay, and then what are the good places to visit? Okay, Goa, some good places to visit, and it has generated this particular response. Now I'll show you. You can see the cost is high, and now as I mentioned earlier, right, you can see clearly input cost is 78%. Earlier it was in the range of 60, right? Now it is 78% because your conversation have increased and your output cost is less. So that's how the that's where it becomes very important for us to manage the memory, and that's what we are going to see now. But before that, let me show you the threads as well. So if you can see, we have threads option available here, where it will show what and all details that we have captured. So you can see user one is the thread name that we have given. Let me quickly show you that. You can see user one was the thread that we have given, and all the conversation that have happened on that particular thread, it has captured. You can see we have asked this particular question, it has generated this response, then we have asked follow-up question and the response. All that conversation it is giving. Let's jump back and let's see the summarization. Now, why summarization is required, as I mentioned earlier, because uh, there is a scalability and efficiency issue. As we just saw that the input cost is higher than the output cost. So memory growth problem is there. If we keep appending full conversation history, the memory grows very large over time, and this leads to a slower responses with higher computational cost. Obviously, if you are storing lot of history, right, conversation, then for that you are consuming a lot of tokens, and every time you are passing that conversation to the agent, then it or large language model, it is going to consume a lot of cost to process that particular history. Then relevance filtering. Not every past detail is equally important. Obviously, in the conversation, it is not that everything that has happened is important. Only essential component we should carry forward, and that is what our agent is going to generate the summary. Then our large language model is going to generate the summary. Then long conversation, obviously for most of the or for any application, long conversation doesn't help. What help is the latest conversation that have happened. And improve reasoning. Summarization help stay focused on the core details instead of focusing on the irrelevant chat, and that's where the memory compression is very much required. And in the GPT-4o model or all the chat GPTs, right, this is what they have implemented. You are keep if you keep chatting on the chat GPT, right, at one point it gives you that message that okay, memory full now, and that's where it starts trimming the earlier responses, and it summarizes and compresses that and then stores it in order to save the cost. And again, this is a wide topic where we can focus on research as well. So if you are interested, I would like to cover a research paper reading for this particular memory management, which is a very good research topic. And if you are interested, you can continue exploring this particular topic. So let's move further. Now, we have recreated this particular model just in order to test this. And now here you can see we have created a message state, but we have created our custom state where we have passed the message state only, which is a type dict, and we have passed the summary in the form of string. So let's execute that. And here now we have created a call model, just a simple function we have called so that we can call our large language model. So if summary is available, we will get that particular summary. And for that summary, you can see we are just adding the state message. So if there is existing summary, we are just adding this particular message on top of that summary, that okay, summary of conversation earlier, and we are adding that particular. So this is just the summary that we are adding. And else if the summary is not there, this state message, that user question that is coming, right, itself becomes the message, and then that we are going to pass to our model, and model is going to invoke the response, right? Basically it's going to generate the response. So this is just to call the model. And if the summary is available, it will invoke that summary. If summary is not there, it will only pass the user message. Simple thing that we have built. Now let's add the summarize conversation function. So in the summarize conversation, if the summary is available, it will create that. If summary is available, then we are just adding this particular system prompt, right? Like this is a summary of the conversation to date. Extend the summary by taking into account the new messages above. If the summary is not available, create a summary of the conversation above. So whatever conversation we are passing to this particular summarized conversation, it will go ahead and generate the summary out of that. And then you can see along with the user message, we are appending the summary as well, summary message, the one that we have created. And then we are invoking the model and generating the response. And also we are deleting all and keeping only the last two most recent messages. I told you, right, whenever we are storing the history, we should store the history for a couple of conversations only. So here we are storing for two. And that's what we have used remove message from remove message class from the LangGraph. You can see we have imported it here in order to remove the conversation. So let's go ahead and execute that. And now let's add a conditional age. So this again is depend on you. If you want to add that, you can add this particular condition. So what this condition is going to do is basically, if the number of messages are greater than 6, then only it will call the summarization tool. If not, then it will not call that summarization tool. So 6 conversation meaning 3 user question and the 3 responses generated by the model, total 6. If it is beyond that, then it will start generating the summary. Prior to that, it will not generate any summary. So let's go ahead and execute that. So now we have added that. Let's go ahead and build the state graph. So again, very simple. We have seen this in the last session. We are defining the state graph. We have added conversation where we are calling the model. Then we have added summarized conversation as a node. So these are the 2 nodes that we have added. Then we have added age from start to conversation, this node. Then we have added conditional age from conversation to should continue, from this conversation to should continue. And then we have added summarized conversation. And as usual, we have added memory as a checkpointer. And let's display this particular graph. So you can see start to conversation. Conversation, we have added a conditional age, summarize conversation, and end. Now this summarize conversation will be called only if this condition is true. This particular, if length of messages is greater than 6. So this is one way of, one smart way of adding the conditional age, should continue. And then it is going to end. So now let's go ahead and test it. Again, we have created thread with ID 1 so that we can trace it on LangSmith separately. And input message, again, we are passing same message. I want to go to Goa. Please help me with the itinerary. Then follow-up message, we are asking where can I stay? And third message, we are asking what water sport I should try. Now let's go ahead and execute. So 3 questions we have asked to our model. Okay, so first you can see it has started generating the response. It is giving to help me create the perfect Goa itinerary. It has created trip length, trip style, all those. Day 1 you can do this, day 2, day 3, day 5, all those detail it has given. For second question, where you stay in Goa depends heavily on your budget. Now it remembers because of memory that we are talking about Goa. So then it has given this luxury, mid-level and all that information. You can go through this. Third question, Goa offers a wide variety of water sports, and it has given like jet skiing, you can do parasailing, you can perform, and all that information it has given. So it has extracted, so it has given responses for those 3. Now 6 conversation are completed. 3 question, 3 responses. So let's see. There should not be anything in the summary now because it will not generate the summary until we are crossing 6 messages. Currently the messages are less than 6. I've added here the description as well. Then now if I'm asking the 4th message, you can see, are there any museum that I can visit? So if you see now, it will start generating the response and then we can see whether it has generated the summary or not. Okay, so it has given the response as Goa has a rich history, reflected it in diverse museums. It has given the museum details. And now let's see whether it has generated the summary or not. Now we have 8 conversations. So, okay, you can see in the summary, this conversation planned a trip to Goa, India. We first determine the need for Goa trips and all those details it has given. So it has compacted. So you can see we have lot of conversation that happen. You can see here plus here. There is a lot of conversation that have happened. Instead of capturing everything, it has captured only 4-5 lines. You can see how beautifully it has created this particular summary, and it is going to store this particular summary only so that it is going to save our tokens. So let's go ahead and see this on the LangSmith. So let's go ahead and refresh this now. Again, we are on same project, so we should be able to see that on the same project. Okay, now you can see we have 8 conversations. So let's open that. The previous 4 plus 4 questions now we have asked. So let's skip the previous 4 now and let's start with the first one. So where we have asked the question, I want to go to Goa, please help me with the itinerary, and it has given this beautiful response. And again, you can see now here you can see the input cost is only 68% versus the output cost is 99% because input we have only asked this one question and output it has generated very long output. That's where the cost ratio has completely changed. Previously it was giving one-liner answer. Then probably you can go ahead and change the prompt in order to generate small answer so that you can test this part as well. Then we have asked the follow-up question, where can I stay? It has generated that as well. But okay, here let me show you now the clear differences. Okay, you can see now 18% from 0 point, what was that, 0.5 or 6%, it has jumped to the 18% because in this memory now we have a lot of things. We have the previous one plus this particular output. Now if we switch one more step, you will see a lot of cost in the input side. So for the third question we have, where we have asked, okay, the third question was this: what water sports should I try? Now you can see these many conversation, 3 conversation it is going to capture, and you can see the cost has increased. And tokens, you can see 1560, 1546 token, and you can see 33% cost is input, 66.71 is the output cost. You can see how rapidly the input cost is increasing. Now imagine if you are having, let's say, 50 conversations, you can see the input cost versus output cost, right? You will be spending hell lot of money in the input cost, right? And that's where the summarization is important. And if you see now for the last conversation, these many details it has passed and it has generated this particular summary. So let's see the token. You can see 60% is your input cost and 39.53% is your output cost. You can see how almost doubled it has increased, right? So going further now, it will not capture all the conversation history. Instead, it will only capture this particular summary. So let's test that quickly. So let's go ahead and ask this particular question. I'll show you how exactly it will save the cost now. Okay, let's ask, what about cruise safari? Simple question. Let's go ahead and see what response it is generating. Okay, what kind of atmosphere are you looking for? So go offer several types of cruise safaris, and it has given these particular details. Now let's go ahead and test that. Now it has only used this particular summary in order to generate the further response. So let's go ahead and refresh this, and let's open this particular node. You can see we have asked this particular question, and then it has generated this particular response. And let's go ahead and check the tokens now. See the cost, 31% versus 68%. You can see the reduction in cost because we have used the summarization. I hope I was able to explain this memory management and why memory management is important. I hope I could explain that with the help of these LangSmith tracing. So LangSmith is a very good tool from LangChain. Please go ahead and leverage this particular tool. You can see how easily you can manage. Now, whenever you are running the code, right, you don't know what's happening behind and how much cost it is incurring. But once you see this visualization, right, you will be able to work on optimizing your cost. And obviously by looking at these tracing rate, there will be a lot of research ideas that will come into your mind, and you will start working on that. So yeah, I hope this was helpful for you, and you like this particular video. So if you like the video, please go ahead and like the video, subscribe to my YouTube channel, and share it with your friends. And please stay tuned for the upcoming videos in this particular series. Thank you so much, and I'll see you soon in the next video. Thank you.